So here's my Ovens River data. First of all, I'll stretch this out so I can see my date. So I have turbidity in NTU, which is a measurement that's easier to make and can be logged by a logger. So often we have more records of NTU than any other manual measurements of suspended sediment. But the suspended sediment and NTU don't always correspond. Turbidity can be caused by a lot of things, and it's not necessarily sediment that's causing it. So in some systems, we have predictable, consistent sources of turbidity that are the same types of sediment. And then we have a pretty good relationship between TSS and NTU. QC are quality control flags that if you download the data from the website, you'll see what they mean. We don't care about them at this stage. And then I've downloaded the discharge in megaliters per day. The water level in meters, we are not going to use this information. To get the discharge, they've used water level, but we don't need to. So the first thing I want to do is see whether I can make up for the missing TSS values by calibrating NTU versus TSS. I'm going to select these two and insert a scatter plot. So my x-axis is always the left-hand column in Excel. So this is NTU. This is why it's really important to have labels. And this is TSS. So I can already see that, look, this relationship, whatever it is going to be very much influenced by a single point. So I'm not anticipating much, but I right-clicked and add trend line. And I'm going to put the equation down here. So I can actually create a TSS estimate from NTU. Because I have a model now, I have a linear model that I can use. So all I need to do is take the MTU value, times it by 3.41, and subtract 13.082. Like I said, this relationship is not great, and we can see that where we do have values, so TSS, the actual TSS measured was 10 milligrams per liter. TSS estimate gives me negative 2.5. Okay, so what's happening is actually where the values are, this calibration curve isn't really representing these points very well. I'm going to get rid of it, and I'm going to not use this. I'll insert a little comment for myself. Not using the calibration curve. It's a poor relationship. So that when I come back to this spreadsheet one day, I can know this. So I would like to know what the load is, Q, suspended. The suspended load is the concentration of TSS times how much discharge there was. My discharge is in megaliters and my TSS is in liters. So first of all, I need to fix those units. So I want to, first of all, have discharge in liters, not megaliters. I'm not going to pretend I know how that works. So I'm going to go to here and I'm going to say, how do I go from 1 megaliter, I'll write it out, to liters. And this is my number. So I can go equals my megaliters times whatever that number was, which is 1,000,000. There's 1,000,000 liters in a megaliter. So this is how much water is flowing out of the river in liters per day. QSUS is this discharge in liters times the TSS that we measured. In this case, we didn't measure anything. And the values we have now are milligrams per day. Milligrams is a tiny amount when we think about sediments. I'm going to drag this down a bit and you'll see what I mean. So, of course, we're not going to talk in milligrams from an entire river. We'll talk in tons. So QSUS tons per day Again, I don't trust myself. I'm going to go 1 milligram to ton. And even if I misspell, Google can deal with this. So equals whatever this value is times the conversion. So this is how many tons per day. I'm going to drag it all the way down so I have all the data. Okay, so this is the value I'm really interested in. And if I look at how it looks over time, I can take the date and add a line, because I can see how the sediment load, the Q, changes over time. I'm not interested in the entire time series currently, so I'm going to create a column that is the year, and I'm going to ask for the year in this date. Currently, Excel doesn't know what type of column this is, so I'm going to go to Format Cells and change it to a general cell. So you'll see that it knows that it's 1990 here. And now I can insert a pivot table and have different years. And what I'm interested in is the QSUS in tons per day, the average. So here are all the different years. I've asked only for 2017 and 18 and 2019, 2020. So all I need to do is take these two values, the average of them is shown down here, it's 3.31, and 2019, 2020 is 10.48. That's that.